Hello everybody. Today we are doing a couple of heap problems, starting with the smallest range covering elements from k lists. Anytime there is a mention of k lists or something like that, then that means it's a heap problem. Okay, so we have k lists of sorted integers in non-decreasing order, increasing order. Find the smallest range that includes at least one number from each of the k lists. So check. Okay. Yep. Okay. The smallest range. So we have in the first example we have three lists, and this is the range we have to return, and we can see that each list contribute at least one element in this range. So 20 20 is present in this list, and then 22 is present in this list, 24 is present in this list. Okay, so that's the problem. And again, the first time I tried doing this, I couldn't do it. I couldn't do it. But actually the solution is very simple. Now that I've seen it, I know it's simple. So what we're gonna do is, well, first of all, the brute force way to do this is to extract all the numbers out of these lists and sort them, and then we can have for example, we can have a list something like this: 0, 4, 5, 10, 15 and 24 and so on, like, right? And we will probably try to pair every single number. So we will try every possible combination and try to see if that pair works. So for example, 0 to 4, does that pair work? Okay, in order to check that, we'll probably have to iterate through these lists and check if each list contributes one number into this possible pair, candidate pair, and we'll have to do that process for all the possible pairs. It's a very bad solution. It's so bad that I have not implemented it. I should do it. It's a good idea to implement brute force solutions too. Yeah, but okay. The actual the real way, yeah, the efficient way to do this is to have a pointer in each list. Let me just so have a pointer in each list. So for example, we'll have one pointer at this. Actually, we're not gonna use k pointers, like one separate point, a pointer for every list, right? We're not gonna do that. We will use one pointer for every list starting from the 0th element. So we will use 4 and 0 and 5, and now we have these three numbers. We can find out the minimum number and the maximum number. So for example, 4, 0 and 5, and from these three numbers, well, we're gonna have k numbers. Okay, we can find the minimum and the maximum, and we don't what was the countries? I forgot. Yeah, so the minimum and the maximum will help us. Well, first of all, since we have chosen one element from every list, we don't have to worry about this condition anymore, that at least one number from each list. That that requirement is already satisfied because we did this. Okay, and we just have to worry about checking whether this current range is the smallest we have seen so far. If it is not, then we keep looking until we run out of bond in any of the list. Okay, I think that's it. That's really about this problem. It's not that difficult. Okay, let's try it now. Let's try to implement it now. First of all, I need okay. So I'll have my loop like this. Let's say true while true. Now I also need a priority queue for getting these small all pq is my priority queue of type int, and that's it. By default this is the min queue. We don't need to initialize the don't need to have anything in the constructor. Okay, but no, it's not gonna be of type int. Actually, it's I want to use pair of let's see pair of well, going through the lists, I'm gonna store the list index and the index at which the actual element is present. Okay, so let's say intent, pair of intent. And how should I determine the actually we need to put something in the constructor. Okay, so AB, let's say, and nums a dot first minus nums a dot b dot first. Oh, no, this is only going to give us the list index. I also need a dot second and b dot second. Okay, yeah, this is just the way to get this smallest element from the queue. Now we could have used triple instead of pair, and instead of doing this we could store the actual element itself in the queue, but this way is fine too. Okay, so let's create result int array of I guess I have to do something like, okay, something like int dot max integer also need max initially set to minimum value int dot min integer. Okay, So while my PQ is not empty, while there are elements in the priority queue. Okay, well, I need to put elements in the priority queue first. Where should I put it? Priority queue dot offer nums well, pair of, right? So I'm just gonna pass in because we'll start from zero. No, I need to iterate over for nums for each list pq dot offer in 0 0 until nums dot last index pair of I, and yes, the first element of pair is going to represent my list index, so that is first, second and third, and the second element is going to represent the index. Okay, yeah. Now inside this loop, list index and index is q dot poll, and current element is going to be equal to nums list index and index, and I'm gonna check whether this current element actually I also need to update my max here. So max is equal to max of max and nums I and 0. So I'll get max from here and current from here. Current is basically my, actually I should call it min, because this is my minimum element and this is my maximum element, and I'm gonna check whether the difference, the range, is smaller than my current range. For getting the current range, for getting the default range that we're gonna begin with this one, 0, 0's minimum 0 and maximum is integers max, and when we sort of, let me result dot 1 result dot 0, this should return 0, because the way this is, no, actually it will not return 0. maybe I should set this to min integer, because we are looking for mini. Yeah, let's this was fine because we are looking for minimum. Yeah, so max minus min is going to be, smaller than this huge number, right? When that's the case, let's update my result at index 0 min, at index 1 max, and PQ is this right time to offer elements into my priority queue? Okay, no, I don't think so. Maybe we're supposed to do it here. So now once we have checked this, it's time to move the index. So we will have our minimum and maximum. Now we need to, if the pointer is at 4 right now, I need to move it to 10 for every list. So I am just gonna check if the index, that is this index, is smaller than nums list index, the list I'm checking in, size. Yeah, if this is smaller than the list size, or actually should I check for +1 actually, right? +1. Yeah, so index +1, if moving the index is actually within the bounds, then okay, then update my priority queue pair of at first index my list index, and I'm not gonna update the list index because I don't need to. Index +1. Okay, so yeah, and at the same time I also need to update my max. Max is max of this one, max of max, or nums list index and index. Yeah, I think that's it really. So return the answer or result. Yep. Okay, let's try to run this. Unresolved references min. I think it's int dot max integer. No, integer max integer min. A and B. Okay, maybe I probably need to fine now. No, no. Okay, so this pair. What did I do wrong? Expecting a closing. Probably not this. This won't change anything, right? Yes. Wall cannot be reassigned. Wall cannot be reassigned on line 11. Okay. 11 and on line 26 and line 11. I don't know, let's what's the syntax error? What's the syntax error here? Lambda. Oh yeah, of course, that's lambda, not a. Of course. Is it maxint, something like this? Minint. I probably should not be guessing. Let me show my resolution. Min value. Okay. Min value. Max value. Okay. We are all set. And we got a wrong answer. Why is that? We got 30 for the minimum value. That's not even a valid. At 0th index min, at first index max. Okay. let me look into my priority queue. PQ. And the value I'm getting min. Okay. This is my priority queue, and the value I got as minimum is 0. Hang on, that's not possible. What's 0? Oh yeah, this is 0. Yeah, got it. This is fine. 0, and the second time. Okay, then we move this pointer. That makes sense. 1 0 0 0. Zero, zero, zero. Okay, this one is at the top. That means that's the minimum. Okay, in second time, once this is out, we have 0 0 at the top. That means so 4 is the minimum among these. 4, yes. And then we have 2 0 2 0, which is 5 at the top, which is the minimum. 1 2 0 1 1 and 0 1 and 1 1. Yes, 5 is the minimum among these 5 numbers. Okay, and then 9, and I think we are fine here. So where did we go wrong? Maximum minus minimum. Let's see how many times we enter this condition. Five. Oh yeah, negative values. Sure, that's the bad part. Negative values. I don't need negative values. I need absolute values. Can I use math or absolute or something like that? Ablis is it available in Kotlin? Five. That's 0. No, something's gone wrong here. Maybe because of this value. So I'm choosing the maximum and then subtracting, and here I'm basically getting this int max value, and I'm checking whether this value is smaller than, and yeah, everything is smaller than int max value. So this is my new max. result. Zero. Result 0, result at index 1. Come on, what should I do? ToString. 30 minutes. Okay. Well, max. Int dot max. Zero 5 5 5 5 5 5 5 5. How did it do? This is the problem. 0 0. So 0 5 0 5 and then 4 5, 4 from this list, 5 from this list, and then 5 5, which, and this is a problem. We can't do this. We can't do this. 5 5. Priority queue is working fine, no problem there. Then I'm checking index plus 1 whether this is smaller than yeah, this is also I think working fine because we haven't got the error yet, any error. And pgroup.offer dot list index, and then this. Oh, I also need to plus here. 30 30. Index plus 1. There was a silly error. And maybe not this. 30 30. Here is the answer. Oh yeah, got it. I also need to break the array. As soon as any list index goes out of bound, I mean as soon as any list becomes empty or the pointer reaches the end of the list, I need to break the array. That's all. Yeah, great. Okay, yep, that's it. And the time and space complexity. Space complexity is going to be k, because k is the maximum amount of our queue basically stores at most stores k elements, right? So that's it. And the result array is a constant time. It takes constant space. and other than that we are not making use of any extra space. For the time complexity, it's well, first of all, we are checking every element of each list, so that's n. Yeah, n number of elements, and we are for the cost of adding and getting element from the priority queue is log k. So that's log k into n, which is good. It's better than n squared complexity. Oh, yeah. And I was thinking, what if we used the priority queue to get the maximum element and used calculated the minimum element manually, like basically what we are doing right now. We can just do the reverse. So let's try that. I don't know if it would work. Yeah, let's try that. In order to turn this min heap into max heap, I think we need to okay, let's first of all reverse this min, and I'm gonna say max value. Okay, and min is minimum of, I don't know if it will work, but we can see, and here it'll give me max, and I don't need to change anything from here. It'll stay actually here because we are calculating minimum manually. Minimum of min. Yep, that's it. Let's try to turn this into a max heap. So I would I think there must be a constructor. What was it called? Compare by. Hang on. How to turn this into a max heap, min heap, max heap. How to turn this into max heap. Reverse subtraction. B dot first. Compare by descending. I'm not gonna copy paste because I need to build muscle memory. Okay. Yeah, so I'm gonna hit constructor compare by descending. It's gonna take Yep, that should work. Let's try. Who knows? Max minus min. What changed? What changed? Zero 5. Zero 5. Okay, so in this approach, this condition became true only one time. That's weird, right? I'm not going to spend too much time here, but just I'm gonna see the value of max I'm getting. I'm into so 5 basically from here. Yes, 5. I think there is a reason we need. I think there is a reason we want our heap to be min heap and not max heap. 5 and then 18. How? That's 18. This one, yeah, 18. Minimum and maximum actually. 0 5 and 0 18 and 0. Okay, cool. Yes. I think I see the problem now. We always want the minimum from the next value. Here it is not changing. Okay. Maybe I can have my minimum set to this value should have been the minimum and as the pointer. Okay. There is clearly more to this than simply changing min max, the ways we're getting min max, and yeah, I'll probably explore this more in my free time. I need to move to the next problem, not this one, this one. Find median from the data stream. Let's remove this. Hang on. The median is the middle value in an order integer list. If the size of the list is even, there is no middle value. And the median is the mean of two middle values. Okay, if there are odd numbers, return the middle value. If they're even numbers, then return their mean. And we'll have to implement this median finder thing. It takes, we have to implement add number function, find median function, and yeah, this question is heap based. We need two heaps in this one, a minimum heap and a maximum heap. Minimum heap and a maximum heap. And let's see how it will work. I'm gonna have a max heap and I'm gonna have a min heap. Min heap. Let's imagine them like a list. Number gets added. Well, whenever a number gets added, we'll put it inside. We'll put it into my min heap. So 1, and at every insertion I'll check the size of the heaps. So I think the idea is that there should not be a difference of more than one element between these two heaps. If for example, if max heap becomes greater in size by say 2 elements, or no, let me think. If there are 3 elements in max heap and only 1 element in min heap, then that means max heap is greater in size by how much? Well, there are 2 extra elements. It should not be greater. The difference should not be more than 1. So we'll probably should I empty my whole heap at that point, or only the difference? I don't know. Let's see. We'll see. And I also need to check that min heap never becomes greater than max heap. Okay, so the 1 is in the max heap. There is 1 element, and yeah, so far everything is good. And then 2 comes in. By the way, I probably need to check whatever is at the top, my top element. If this 2 is greater than my top element, if that is the case, then it will replace my top element. Now, the reason I'm using min heap and max heap, the reason I need max heap is that it will store the first well, if this is going to be the array, this is going to be the, if these are the elements I'm gonna have, the answer is 2. I know, because there are odd number of elements. How would I arrange these 3 elements into my 2 heaps? Max heap is going to store all the minimum elements of the first half. I don't know, I read about this. Now I've forgotten about it. Why exactly do we need 2 heaps? Okay, let's try to solve this and try to figure that out as we go along. Yeah, max heap is priority queue. It's gonna student and compare by descending. No, it dot value, this is wrong, but okay, we'll worry about that later. And heap is min heap by default. Min heap okay. IT so if my max heap is empty, or this element, this number is greater than, is smaller than, if a max heap is empty, max heap peak, then max heap dot add offer add, I think it's the same thing on this number, else min heap dot add number is smaller than max heap peak, so 1, and this 2 is definitely not smaller than 1, so it will go into min heap. Okay, they are at this point they are same size. Then 3 comes in which heap would 3 go? Is 3 smaller than 1? No, then it will definitely go into the min heap, 3 here, but the min heap has become greater in size, and that is not acceptable. So maybe now I think we need to push all these elements into this heap, max heap. But I think this looks perfect according to me, because 2 is the answer I need, and in the return in this function I can have some logic and basically return this number. Okay, let's see. I will check if my, now first of all the difference part, if max heap dot size becomes greater than min heap dot size plus 1, if it becomes greater than 1, yes, min heap dot size plus 1, then transfer all the elements from max heap into min heap. pop. We'll see the implications of this. One more condition. If min heap becomes greater than max heap, then transfer all the elements into min heap. Well, we basically transferred all the elements. If this step happens, then that would make our min heap greater than max heap anyway. So do we maybe I'll have else here. Min heap dot offer max heap pop. Yeah, so min heap in dot size. Now when I push 2, okay, first of all 2 will be popped off, and since this is a max heap, well, this is a min heap, right? Yeah, so 2 will come here, and then 3 will come here. 3 min heap will be empty. This is not quite what I wanted. 3 now 3 is at the top. This is definitely not what I wanted. Can I have some hints? Something here. If all integer numbers from stream are between how many? Important points for the last discussion. That guy was asked to improve the solution in the follow-up question. Okay. What if I change this idea? What if, let's start over. So 1 comes in, next is 2. According to this condition, if number is greater than at max heap stop, if 2 is greater than, yes 2 is greater than that, then add it to my min heap. Yes. Now min heap size 2 is greater than max heap size 0 plus 1. 2 is greater than 1, yes. So we'll transfer all the elements into min heap. So 1 and 2, and this is empty now. Max heap is empty now. This condition will not run. Now when 3 comes in, it will go into max heap, because max heap is empty. Okay, now max heap size is not greater anymore, but min heap size has become greater than max heap size. So that means we'll pop poll min heaps elements. So when we pop off all the elements, oh god, that doesn't make any difference at all. We just ended up with the same heap, same. But no, but yes, 1 goes off, 3 will stay at the top as always, but I want my 2 at the top. I don't know, maybe I'm having something, of course I'm having something wrong. Check if one of the heap is thread safe. No. Well, that's what happens when you don't actually understand the concept and just think you know the algorithm. Return the median of all elements so far. Hang on. Median of all the elements so far. Okay, so this method doesn't just get called at the end. It can be called at any time. Okay, that doesn't really help us. So if 1 comes in and find medium gets called, well, 1 is in my max heap. So what? So basically, give them 1 from the max heap, and then 3 comes in. No, 2 comes in. 2 is 2 is in my min heap. Well, according to the peak plus max min heap dot peak divided by 2. Now this is what I actually want, because the basic idea, the real reason we are using a min and a max heap is because we want the minimum and maximum element, the one we need on the top. So you can just simply do this. Now We have time, we have time. So if 1 stays in my max heap, I gotta make sure that 2, which is the next element, stays in my min heap. And by that, if find median gets called after 2 insertions, I will have something to give to them. So yeah, I gotta make sure that num2 is smaller than, is it smaller than, no, 1, and then 2 is not smaller than, yes, so it goes into the min heap, and now both heaps have same size. This and this, yes, cool. And well, logically, next element should go into, well, it doesn't really matter where it goes. If there were 4 elements, 1 2 3 4, well, 3 comes in, is 3 smaller than, is 3 smaller than 1? No. Then min heap gets added to the min heap. Somehow this condition is wrong. Or maybe I can have a while here. Now if 4 comes in, four comes in. Okay, let's get help. Let's get help. In find medium on data sheet problem. What is the idea behind having a min heap and a max heap. How does keeping two heaps make it easier for us to find the median? That is to split the numbers into two halves so that median is always sitting at the top. Max heap, smaller half, left side, okay. Max heap, larger half, it's the right side. So the data looks like max heap elements are smaller than or equal to max heaps elements are actually smaller than smaller half, left side. What does it mean left side? Size or size. So the left side can have one extra element. Max heap 135. If there are odd numbers, then we'll have one extra element in the max heap. Okay. Then 5. Okay. Max heap is 3. Yes. Okay, so the idea is that if max heap size is equal to min heaps size, actually it's a property, not a method, then that means there are even number of elements. Then we need to do it this way, else return basically return max heaps peak. Two double we'll verify this later. You would without heap you would sort every time, that's n log n. With heaps, that's log n, and getting median is a constant time operation. How insertion work? Add a number to correct heap. If smaller, then if it's smaller, this is right, then add it to max heap. If larger, rebalance the heap. Left bucket all smaller numbers, right bucket, so the max heap is actually going to contain small numbers, right heap is going to contain large and stuff. Okay. So middle split, cool. I think that's really it. Let's remove this condition and let's hope for the best. What's the problem here? Double. Okay. No, not quite what we wanted. So if number is smaller, 2 is not smaller. Let's print max heap, print min heap. So 1 2, okay, 1. My median should be at the on the top of the max heap, right? Yeah, so the median element should always be at the top of the max heap, but here it's at the top of the min heap. Okay, so who is the boss here? Is it the min heap or max heap? Two is not smaller, and 3, well, here let's say I do this, and yeah, no, because this method gets called 2 times. Uh, 2 plus 1. See, the second time I'm getting the right answer. The first time, for some reason, if the size is same plus, oh, maybe it's the order of addition and subtraction. Yes, it will not work because I'm not balancing them right. Null pointer cannot work because the return value of is null. Yes, that's why we need to we need to rely on the max heap. There will always be an element in the max heap. But how? This step ensures that my min heap never goes out of. So min heap dot size max heap. If this becomes greater, max heap. Yep. Okay, let's see the solution. Oh, don't tell me. Is smaller than or equal to, that's one mistake. If my max heap size, okay, this is fine, as if of min heaps. Oh no. Oh, such a silly mistake. That's such a silly mistake. Well, if my min heap size becomes greater, then why am I adding elements to the min heap? I should be pulling elements from the min heap, not adding into it. Okay, let's see if we can do without equal to sign. It looks like we can't. So yeah, let's put that sign there. Smaller than or equal to. Smaller than or equal to. Output limit exceeded. That's a huge. Yeah, remove that print statement from there. Yep. Yep. It will work now. It will work now. Yeah, it works. It works. And getting the minimum is a constant time operation now, but I guess I'll never appreciate that idea because I have not implemented the brute force solution. Maybe I should do videos where I implement just the brute force solution. I don't know. Yeah. Okay. I thought I'd stop the recordings. Last problem for today. Task scheduler. I have seen this problem too many times. I don't even need to read the description now. But yeah, still, we're given a number of. We are given an array of CPU tasks, each labeled with the letter A to Z, and a number n. Each CPU interval can be idle or allow the completion of one task. Task can be written in any order, but there is a constraint. There has to be a gap of at least n intervals between two tasks with similar labels. These are labels A B A B A A A B B B. We don't care about labels. We only care about their frequency. So for example, if there are 3 A's, right? So 3. There are 3 B's. So 3 B's. Okay. One more 3. 3 A's, 3 B's. Return the minimum number of CPU intervals required to complete all tasks. We basically need to first of all have a priority queue. PQ, it will give us the task with most frequency, so it's a max heap. Priority queue of int, and compare by descending ID. Okay, it's a max heap. Let's maybe I need to create a hash map. let's see. So for tasks, for each wall map is a mutable map of character and int. Will task for each map dot task is map dot get or default task 0 and +1, and that shall initializer that will fill my map frequency map. Now I will fill my priority queue with that. Map dot values I can let me pull up the documentation. Priority queue Kotlin. Google. Okay, Android, fine. Queue capacity comparator mutable collection. Sorted comparator contains for each iterator offer remove split to okay. I'm just looking for a way to add maps value list to this P priority queue without like writing an array or like that, something like that. Okay, we'll see about that. And so while my priority queue is not empty, and I'm gonna have one more inner while loop, and this is actually simulating CPU cycles. Okay, so the number of time it runs, I can define my cycle here for cycle set to 0, and while cycle is smaller than n, each iteration I'm gonna plus, we need to return the minimum number of cycles. We don't really need to cycle 0. Okay, let's have a result variable here. Result 0. Similarly, cycles. Okay, so my PQ dot poll, because my priority queue contains frequencies, so 3 and 3 frequency map, right? Because my I also need an array remaining, a mutable list actually, mutable list to put the remaining tasks into this list, because we can't process all the tasks in this cycle. So I have, what is the size, what does size of my priority queue represent? It represents the number of tasks I have, or the number of labels, in this case 2, and the content of the priority queue represents the frequency of each task. So one cycle means I did some task. In one cycle I do some task. Okay, now if I did that task, what I will do is I will poll that frequency from my queue, like here, like okay, right, I polled that frequency from my queue, but because number is 3, frequency is 3, then that means I have 2 more tasks in this label, of this label, right? So I'll put those into, so I'll put 2 into my remaining list, and what, you know, and I'll put everything back into my queue from my remaining list here. Yeah, so let's say remaining dot add this frequency minus minus. Now I don't want to add okay, let me wall frequency is this. If frequency is greater than 1 or greater than 0, only then add it to my remaining list. Frequency, let's say remaining frequency. Okay, that shall do. cycle plus plus, fine. And here in this outside of this inner while loop, I will add the remaining tasks back into my priority queue. So remaining for each pq dot it. Okay, and for the result, it's well, if priority queue is empty at this point, if priority queue is empty, what does that mean? There were even after this step, if priority queue is empty, what does that mean? That means we're basically done with everything. And else maybe plus is equal to else cycle. Okay, let's say if this was the case. No, actually it depends on the end too. Okay, we know one thing, that the result is never going to be less than the size of the array. This my remaining list should be inside the loop. Okay. Why is it not working? Let's ask GPT how to do this in more in Kotlin way. This is all idiomatic. For each is actually a map entry, not just a key. Map values for each. Okay, map values for each. Map values for each. Okay, will work. Line number this one. Exception is null. Really? How can it be null? Of course it can be null. While priority queue is not empty, and cycle is smaller than n, because actually I always I find this the most confusing part of the problem, because I always forget its function. It's here because, well, we can only execute n number of tasks. Let me read that again. There has to be a gap of at least n intervals between two tasks with same label. How are we making sure that we are not doing how are we making sure that we are not doing this two tasks of same label? Well, we are actually polling from the queue, and what we are polling from the queue, literally that represents the frequency of the task. So when we poll that, so that means the task is gone. For this cycle, the task is gone from the priority queue. So there is no way we can execute that task or task of that label again in this cycle. And we run this cycle for n times, meaning that this is our gap. Okay, yeah. False. Okay, what's the problem? Okay, what's the problem? Let me verify everything is fine till this step. Let me find my check my PA priority queue. 3 totally good, everything looks fine. 2 okay, everything good till here. While my priority queue is not empty, we are creating this remaining list. Good. Okay, that's right, because in this cycle, in the first cycle, we could only do we could only do one A, one B. So now we have two A's and two B's left. In the next cycle, we have one A and one B left, and then there is none, and which is fine. If my priority queue is empty, I'm saying, then if my priority queue is empty, then else cycle. Maybe there is something wrong with how I'm calculating my result. 2. Four and 6. My priority queue was not empty till here. So cycle, 2 cycle, 4 cycle, 6 cycles. Can I is my priority queue empty here? It should be. Just making sure. Yes, it's empty here. We can't have 0 cycles, or maybe we can have a cycle starting. Let's see. I don't know. This is just a guess. No. Yeah. Wait. Wow. It worked for first case this time. If priority queue is empty, well, let's see. If there is only one A, and N is 2, then we'll have, let's test this. Let's create our own test case, and let's remove all these extra elements. Okay. Well, we only have one A, one C, so that means at this point my priority queue will become empty. If it is empty, then N, that means N is, let's keep it to 2. Okay, for this case it works. Let's keep it to 1. Now it should also work. Okay, it does not. N is 1. What is this 2, 3? Oh yeah. Output 673. How? Well, A means this loop will run only one time, so A gets executed. There is nothing in remaining. Hang on. If frequency is greater than 0, then remaining frequency minus frequency is greater than 1. Zero. Let's see. I don't know. One. If frequency is greater than 1. Yeah, it will not work. I'm just guessing here. I don't know what's wrong really. I don't really know what's wrong, so let's just see. Remaining count is 0, Q is not empty, and frequency is greater than 1. Dot cycle for each. I'm offering that into my queue. If queue is empty, then count. If queue is empty, why is that? Cycle else n plus 1. If Q is, I don't know. If priority Q is empty, count maybe start from 0. No. Okay. 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 If queue is empty, I'm adding my cycle. Why does it work with what does priority is empty mean at this point? One block of CPU cycle of size n plus 1. If cooldown is n, same task can repeat only after n intervals. So one cycle is n plus 1. Okay, same cycle is n plus 1. That's a okay, different. You're trying to execute up to n plus 1 different tasks. At this point, after the inner loop, PQ contains tasks that are still remaining after this cycle. So if all tasks are finished, no idle time needed. You only add the actual work done. A, B, and done. So we used only 2 cycles. Okay, no need to force this. Okay, if that's not the case, tasks are still left, so we must complete full cycle of, even if we did not have enough tasks, we insert idle time. A idle. Okay, that makes it clear. A idle. Even though only one task was done, we must add. So but my priority would not be empty at that point. Let me verify that. I can't trust these things. So if my A right, A and N is 2. I asked what an empty PQ mean. This. Yeah, it was only empty in the last case. Good. A idle. Alrighty. If work is unfinished, force full cycle. If work is finished, only count actual work. If work is finished, when the priority queue is empty, all the work is finished. So cycle Do we ever lose the value of cycle? Right, we must lose the value of cycle at some point, because it becomes 0 if it is not. If cycle's value is not used here, then we lose the value, right? If my priority queue is empty, no. Okay, yeah, if priority queue is empty, then we use cycle. Only then we use cycle value. I think it makes sense. It makes sense. I think I got it, what it's trying to say. When this value is true, we know idle time needed, and here we are basically forcing the forceful cycle, and the answer can never be smaller than the size of this list. Okay, cool. With that, I am going to end this video. I don't know, I'll probably sleep on this problem. Maybe I'll get it tomorrow. Bye bye.